Good afternoon. Thank you all for joining me today. My name is Zakir Quabili from Western Digital. I'll be covering the project from HDD Dynamics. I'm the backup speaker as Chris Peterson from Dell was unable to make it in person. I'd like to share with you an area that is valuable to all companies reliant on hard drive performance or designing for hard drives or its enclosures. And the area is HDD Dynamics. The term RV was historically used for the hard drive dynamics, but it's actually much more than that. It includes disturbance from acoustics or linear vibe, etc., all affecting the hard drive performance. The disturbance and the dynamics in the chassis are increasing, while the hard drives are getting more and more sensitive to these disturbances. The disturbances are increasing because of the more powerful IT machines are needing higher cooling, and for air-cooled machines, that means faster fans. For the hard drives, as you know, the capacities are increasing, and we're compacting more tracks in the disks, more disk in the drives, meaning thinner disk, narrower tracks, and getting more and more sensitive to the dynamics. The goal of this group is to provide tools and guidance for measuring as well as to provide a communication template. I will cover some of the key parts we ensure are in this tool. This is a tool that's supposed to go into a slot of a chassis to characterize the dynamics of the slot. The dimensions are the same as a 3.5-inch drive. So the features are same. It doesn't affect the airflow. The material is aluminum. The mass is about 680 grams from the consensus of the group, and the center of gravity is right around a hard drive. So it acts just like a drive in the slot. We also included an I/O connector to capture the structural vibration transmission from the backplanes. And this is a 3D printed part, so it doesn't have to be ordered from a hard drive company. We have 2 microphones going top and bottom. It's separated by a spacer to capture the acoustics. It has 6 accelerometers sensors around the casing to capture vibration. And all the cables from the 8 sensors go out from the slot in the back. And it comes out as a flat bundle to just easier flexing. We have also included a strain relief features to safeguard the cables. All the screw threads are generic, so it doesn't need any special HDD screws. So while the microphones capture the acoustics, the accelerometers capture the linear vibe and the rotational vibe of the disturbance. I will cover a little bit later on how we decided on the locations of these sensors. On the cables coming out of the surrogate, we had a choice of round or flat. We decided to go with a flat for easier flexing, as quite often these drives go into a carrier with very tight space constraint. These are the microphones, just to give a rough idea. One on the top, one on the bottom, there's a spacer. We have O-rings placed. This helps to hold the microphone in place as well as to maintain the concentricity when we are assembling the surrogate. The microphones are held in place by pressing the cover to the base. Also, after the assembly, the top surface of the microphone is slightly below the surface of the surrogate. This is to make sure there's no turbulence and also for the safety of the microphone as we put it in and out of the chassis. Okay, on the strain relief side, there are 2 features. One is the cables go around 1 extra loop before exiting. And second thing is, while exiting, they are pressed between 2 rubber strips. So while the accelerometer cables can be changed if damaged, the microphone cables are sort of integrated. So if any damage happens, it has to go back to the manufacturers, which is downtime as well as can be quite expensive. Okay. So last year, we actually released the acoustic surrogate, which is only the microphones. This year, we're looking at the including the combo surrogate, including the accelerometer. So there's a little bit more cables to manage. I do have a sample if later time somebody would like to have a look. Okay. So the sensors do have requirements to ensure a consistent and reliable measurement at the disturbance levels across all the manufacturers. So these traits shown here has to be met. We also had to define the axis as an X and Y can be interpreted differently by different companies. So with the group, we had this definition. So along the length of the drive will be L axis, along the width will be W axis, along the height will be the Z axis. And this was important for the vibration nomenclature. On the data acquisition systems, there are a lot of choices. We tried to, the number of channels required is 8 channels. We intentionally kept it that way because most acquisitions are 4 or 8 channels. And in the white paper, we do have a table with some specific recommendations. Okay, so as mentioned earlier, the legacy term for the audio vibe is RV, but as you can see here, we do resolve for all the 6 degrees of freedom. There's quite a bit of discussion on the layout of the accelerometers. There can be many choices. Eventually, this is what we agreed on, based on having 3 accelerometers in the Z direction, which is the more important one for the HDD dynamics. We had 1 in L direction and 2 in W direction. And the linear vibe are resolved with just average in those directions, and the rotational by the sensor and the distance between the sensors. Okay, so it was ascertained by the group that the interest range of vibration would be less than 3 kilohertz. So we wanted to make sure there are no modes of the tool in that frequency range. And through simulation and through measurements, we later confirmed that the lowest resonance is around 3.4 kilohertz. So it's important to note that although for vibration, we're looking at below 3 kilohertz, for acoustic disturbance, up to 20 kilohertz can be relevant. Okay, so the acoustical measurements using the new tool has just begun. In this case, we compared to a phase 1 surrogate, which was released earlier, which is acoustic surrogate. This is measurements done in a chassis at full fan speeds and in 2 different slots, one on the left, one on the right, and shows a qualitative agreement between the 2 surrogates. So for all companies talking about dynamics, it's important to have a common means of data presentation and risk areas. This was something that was presented last year on the acoustic surrogate, and this is available in the OCP website. So the intent here is that 1/3 octave band data is plotted, and the risk bands are overlaid on the dynamics. So this way we can, just to give an idea, the green would mean no issues to hard drives, yellow levels would mean cautious levels, and red would mean performance impact to drives. So similar to the acoustical data presentation and the risk areas, our intent is to have something similar for the vibration communication as well. Now, this is very much in progress, and we welcome all inputs. And here I'm showing just a sample of a linear vibe on the left and a rotational vibe on the right. But this is where the project is at this point. We're sort of defining this area. Okay. So in summary, this group is providing tools and guidance for measurement and also a template for the communication. And this is an area that is valuable to all companies reliant on hard drive performance and designing hard drives or its enclosures. Okay, so for such a tool, the benefit to the industry is scaled by the participation. And we appreciate your support and use of this tool as we continue to develop it. Okay, thank you again for attending the session, and we have covered quite a few areas on the application space, technical side, as well as the communication. If there's any area I would like me to elaborate, I'll be happy to do so. Thank you.
If there are questions, there are mics here. Somebody wants to come ask a question? Any questions?
Sorry.
If you go ahead to the mic, you can ask your question.
How are you? El Ramirez here. Is it recommended nowadays to keep the RPM of the system of the fans at 70% limit, or below 70% RPM out of 100%,
Okay.
to be able in the future to reduce the acoustics?
Okay. So I am not aware of any particular recommendation based on just RPM itself. I think it goes by what the acoustics disturbance levels or the vibration disturbance levels are. So if you're talking about very high RPM fans, then 70% might still be pretty high. Yes, it's a moving target from both sides as the chassis are increasing in RPMs and the drives are also getting more sensitive.
Yeah.
So we sort of define it as of now more on based on the actual disturbance levels than really recommending a particular fan speed. Yeah.
Right. I kind of sort of been reading the fact that you really don't want to obviously run a 90% or 100%.
Right.
Because that can be
Most cases, yes.
very, very disturbing in a way.
Yes, yeah.
So the other question that I had is it fully recommended for sure to have isolation at the carriers, between the carriers if you're building a massive storage array, for example?
Yeah, definitely. Isolation helps the vibration side for sure. Yes, and from drive standpoint, we do have some enablers on the vibration side, but whatever enablers the chassis are able to incorporate is of course beneficial. Yes.
Is it possible to borrow from you guys, WD, a surrogate for testing, or how's that?
We have helped quite a few. I mean, we have been on site many companies to test. For our internal use, I've actually did send the system and sort of train them. But for a customer, we haven't really sent our system. I think I would rather support it.
I think so.
Yes.
Now that you mentioned, because you really understand the data. If you don't understand the data, what comes out is
yes. Eventually, even if the customer do the testing, we'll still have to analyze the data ourselves.
Right.
Yes, absolutely. Yeah.
Okay. Thank you.
Yeah. Thank you for the questions.